Write the following description in both degrees and radians. 5/12 of a circle. So, I mean, you're going to see many different representations. I mean, they'll say, like, the hand movements on the clock and things like that. And be very careful with that because you always have to remember that, like, for instance, the hour hand of a clock, it doesn't, if you're at 1 o'clock, I mean, it's exactly on the one. But I start going to 1:20, 1:35, 1:30, 1:40, it's not going to be exactly on one. It's going to be somewhere between one and two, and and how far between is going to be based on how far through the hour I am. So always be aware that that minute hand or that hour hand is moving the entire time that you're looking at a typical clock measurement with the hands and faces and stuff like that. Um, so be sure that you're aware of that. It isn't like it's at 1 o'clock exactly, and then right at 1:59:59 it stays there, and then exactly when there's two, this goes all the way to two. No, it's moving steadily between one and two as the hour progresses. So always keep that in mind whenever you answer some of the questions. And some web work questions ask you about the hands of a clock and what's the angle that's moved by between the if I go from like 1:30 p.m. to 2:45 p.m. what's the or if I say at 2:45 p.m. what's the measurements between the hour and the minute hand. You're taking that kind of stuff into consideration as you're doing it. This one's a pretty easy one because 5/12 of a circle, if I'm dealing with degrees, is 360 degrees. If I'm dealing with radians, is 2 pi. So I do the 2 pi first, and I get 5 pi over 6. Or I can say it's 5/12 times 360 or get 150 degrees. Or I could have done 5 pi over 6 and made it 150 degrees by, translating it. So whichever way you chose to go about doing it, I'm showing a couple different pathways here. But the two answers are 5 pi over 6 and 150 degrees for the question being answered here. But I could have used one to find the other. I could just start with 5/12 of a circle and just interpret a circle to be a different thing each time. Whichever way you do it, you should get the same answers.